Hi guys, and welcome to part 3 of this series on classifiers. So in part 1 we talked about some very fundamental concepts of classifiers, how data sets work, how vectorization works, how model training works. We used a pretty simple example of a vegetable classifier, so putting vegetables in various containers. So in its very simplest incarnation, that is a classifier, right? But doesn't really have any real-world business applications. But it demonstrated classifiers in their simplest form nonetheless. In the second video, in the second part, we talked about just setting up your environment to build a classifier, and getting your packages installed, setting up your environment, and all of the different tools you need to develop a classifier, or how we're developing classifiers in this series. And so we got our pipeline set up as the final step in the second video. And so today what we're going to do is continue that by building out some of the functions in this pipeline. So today I'm just going to go, or in this video, I'm just going to go through the first 3 steps of the pipeline, which is creating the data set, pre-processing and splitting the data, and what's called feature extraction. So what I'll do in this, for the data part of it, is I'm not going to start coding or like typing out all the data. I'll just copy some data that I have here, and then we'll discuss it. So first thing I'm going to do actually is just create a couple of a little bit of documentation for these functions, just to explain them a little bit better. So this first function creates and returns mock spam slash ham data frame. So spam is bad email, is email we want to avoid and we want to weed out, and ham is good email. So it's kind of a bit of a play on the words, like spam kind of rhymes with ham, but spam is email of low quality or is undesirable email, and ham is the good email. So I'll start off by copying a data set here without having to type it out, and that'll just speed things up a little. I don't think there's any need for me to be typing this out. So the data set is as follows. We have text and the labels. So in the first video, the first part of this series, we discussed the vegetable classifier. Here we have a little bit more of a complex data set, in the sense that it's not just single words in our data set, it's actual entire phrases, right? So and this is part of the reason why we vectorize, right? We convert things to vectors. This data has ends up having a lot more features, a lot more words, so it takes a lot more processing power to process a data set like this. And vectorization is a way of making that processing more efficient. When we feed a set of vectors to a model, it's a lot more efficient than feeding a set of words. So I would say that the efficiency becomes much more apparent as the data sets get larger, and the reason for using vectors and for vectorizing data become much more apparent as data sets get larger. So the next thing we're going to do with this, and as a final step to this creating the spam data set, is just returning a data frame. So PD, we're going to use pandas to return a data frame like this, and just like that. So that's the first step, is just defining the data and returning a data frame. So the data frame, what it does is it converts this data into kind of like a spreadsheet format of data, like a row and column format. And so a lot of the process of a classifier is really manipulating data and getting it ready for the next step. And then eventually to the training step, and then after that the evaluation phase. So the next step after that would be step 2. So let's add a little bit of documentation to this. So this converts text to lower case and splits data into training and testing sets. So this is another thing we discussed in the first video that we did, is that we separating data into training and tests. Sorry, not test sets, right? So we used 20% of our data for testing and 80% of our data for training. And you can see that I have a default parameter here that defines the test set as 20%. So the next thing to do is to define our text, which equals the data frame, the text dimension of the data frame, and we're just going to set this to lowercase. So the main reason for setting everything to lowercase is to make sure the data is consistent. So this is part of cleansing data, pre-processing, splitting data, getting data ready, and making sure it's consistent across all of the different rows and columns of the data. So X is equal to data frame text, and Y is equal to data frame label. So the next step after that is to run this function called train test split. So this function is that step that we discussed, where you're training. You're not training. You're breaking the data up into training and test sets. So test size equals test size. That's the test size parameter that we're passing in. And random underscore state equals random underscore state. So that's just a seed. 42 is just a seed. It's seeding the data. Setting a test size and defining the dimensions of the train test split. What we'll get out of this is data split up into training and test splits. So the final step that we're going to discuss in this part today, part 3, is feature extraction. So we'll just add some documentation here. Vectorizes text using term frequency, inverse document frequency, and returns vector. Actually, I'm not going to do that. I'm not going to return a vectorizer here. I'm just going to do that. And vectorizes data using TF IDF and returns matrices. So we'll just leave it at that. And no, so this step here is X train TF IDF equals vectorizer fit transform X train and X test TF IDF equals vectorizer transform X underscore test. So this is that step we were talking about where we are converting all of these sets of data, this text, into vectors. So this is the vectorization step. And it's doing the vectorization on both the training and the testing set. So we're going to return the tuple train TF IDF and the test TF IDF. Just make sure I've got this right. TF IDF X. This is lowercase here. Okay, so this function is just that feature extraction function. It's vectorizing the data and it's returning that vectorized data in two sets of data, one for testing and one for training. So that's the conclusion of part 3. We will proceed to do model training, model evaluation, and live inference in the next part. And then we'll build a function that's going to run this pipeline. So thanks for watching, guys, and I'll see you guys in the next part.